Good morning, everyone. Yesterday we were talking about the unit circle, and we were able to place the degree measures and the radian measures on the unit circle. I'm just taking the unit circle we were working on, where we had divided the top half of the circle into 4 equal sections. We also did another circle with 6 equal sections on the half circle, but I just want to focus here. And today's lesson is going to take us through how to find the coordinates at these various locations along the unit circle. And we really have to venture back to geometry, where you learn some special right triangle rules. So let's say I want the coordinates on the unit circle at 45 degrees. Well, first we have to realize this right here that I'm drawing over top, this is like our y-axis. This here is like our x-axis. And the center of the circle is like our origin. So if we're going to locate the coordinates x comma y at this location on the unit circle at 45 degrees, then we know we're going to have to go from the origin, we're going to have to go right some and up some. And this is going to create the x value and the y value that determine the actual ordered pair at that point. Okay, so we know a couple things about this right triangle we've created. We know that we do have a right triangle. We know that the hypotenuse of this right triangle is 1. And that's because we know we're working on the unit circle, and by definition, the unit circle has a radius of 1. Okay, so that's what we know at this point. Now I'm going to reach back into your memory and mine, and we're going to talk about some special right triangle rules. So what I did right here is I copied down the special right triangle rules of how the sides are related in a 45, 45, 90 triangle. And this is, the font's a little small here, so let me actually bring this out here and make it a little bit bigger, a little bit more exaggerated. So the rule says that if this is a 45-degree angle and this is a 45-degree angle, then these two sides, the two legs of the triangle, will be equal, and the hypotenuse will be equal to these legs times the square root of 2. So let's see how that affects our unit circle at 45 degrees. So I have this other picture here for you right here, and it's very light, but here's that portion of the circle. Here's the triangle that we drew earlier on the laminated sheet. Here's the 1, we knew the radius, and here's the origin. Now here's our x, and here's our y. So if I'm thinking about this triangle, when I pull it out to the side, let me actually make that a little bit bigger as well. I know this is 45 degrees, and so is this, and this is 1. And I know that these two legs are A. Well, the only measure I have is this 1. And this 1 hooks up with A root 2. So this is generic, this is specific. In our specific right triangle, the A root 2 side is equal to 1. So I'm going to set that up as an equation. It'll look like this. Let's move this down. I'm going to say A square root of 2 equals 1. Solving for A, I would just divide both sides by the square root of 2. That'll cancel them out here, and that'll give me A equals 1 over the square root of 2. But we know from our work with the unit circle and pre-calculus, we don't leave the square root in the denominator, so we're going to rationalize the denominator by multiplying the top and the bottom by a version of 1, root 2 over 2. So our final answer here for A is going to be root 2 divided by 2. And since both of these legs are the same value, we're done. So the x coordinate here is root 2 over 2. And the y-coordinate is also root 2 over 2. So if I bring that back to my circle that we were working on earlier, I can see that x is equal to root 2 over 2, and that y is equal to root 2 over 2. And so the coordinates here, root 2 over 2, root 2 over 2. And those are the coordinates at 45 degrees. Now, using the same logic, you can actually get your coordinates at 135 degrees because you can see the reflection of that right triangle across the y-axis. So you know that this is going to be 1. These are your 45s. So the coordinates, this value is going to be the same as this value, just negative because we're moving to the left. And that this value will be positive root 2 over 2 because we're moving up on the y-axis. So the coordinates here at 135 degrees are going to be negative root 2 over 2, positive root 2 over 2. And that just continues on at the bottom of the circle. So if we come to 225 degrees, we're coming left and down. Here's your 45, here's your 45, here's your hypotenuse of 1. So we're going left and we're coming down. So this will also be a negative root 2 over 2. So my coordinates at 225 are going to be negative, negative. And then finally over here at 315 degrees, coming to the right, and I'm dropping down. 45, 45. This is my hypotenuse. So now from the origin, we're going right and coming down. So we'll assign this the negative. So my coordinates at 315, positive root 2 over 2, negative root 2 over 2. And while I have this up, let me just mention there are 4 other coordinates that we know pretty easily just because the radius is 1. We know that at 0 degrees, the coordinates will just be 1, 0. We know that at 90 degrees, we're talking about 0, 1. We know that at 180 degrees, negative 1, 0. And at 270 degrees, 0, negative 1. So there you have it. We have most of our coordinates fixated around the unit circle. In the next video, we'll take a look at what the coordinates are going to look like at our 30-degree measure, our 60-degree measure, and so forth.